I will demonstrate how to use IDE to develop your product code. I show you how to run and compile your Java code from my distribution, the code skeleton for your product. Right? But some of you might prefer to use the IDE to increase your productivity in terms of developing your source code. So I'm going to demonstrate that using Eclipse. Eclipse is open source Java IDE. They also have IDE support for C++ and so on and so forth. And you have to download the correct version of Eclipse for that. And by no means I'm asking you to use Eclipse, right? You can either do your development using Emacs without any IDE, or you can use another different IDE. But the point is, no matter which IDE you choose to use, the general principle behind IDE is the same. So I'm going to use Eclipse just for example, but you are not required. You are not required to use this, right? Just to show you how IDE might help make code development easier. And then I will spend, like I promised, 10 minutes to give you an overview of Java. So many of you, based on my poll I did last Wednesday, many of you, seems that many of you have already learned Java in the past, which is good news for me. But nevertheless, I will use 10 minutes of my time to give a quick review. And for those of you who have no experience or little experience with Java, that's a good opportunity to catch up as well. After that, I will come back to finish the last part of the discussion on SQL. Then we move on. We move on to new topic today. Hopefully, we can do that. Okay. All right. With that all said, let's go with Eclipse first. So Eclipse is an open source IDE environment. I provide a link on the course homepage for you to download the Eclipse Java IDE, and you can choose different distribution depending on your OS. Right? So you can choose the distribution for Windows, Unix, or Mac OS. And once you open it, it asks for a workspace directory to a workspace. Typically, the default directory they supply is good enough, which is what I clicked just now. The workplace is basically a folder where you, by default, Eclipse will store all your source code. Your development effort goes to that folder. Okay? And you are in this interface, and the first thing you do is you want to new a Java project, right? Obviously. And then you give a project name for it. For example, you call this utrack. Okay? And Eclipse itself is developed using Java. So in its distribution, it comes with a Java compiler, which is Java, in this case, Java Standard Edition 1.7. In your system, you might have another Java compiler or Java environment installed, which is the case in my system. So you can choose that, but typically the default one is good enough. Okay? And then it asks you for project layout. This is fairly common in a lot of IDEs, where they ask you whether you want to place the source code and the class file in the same folder, or you want to separate them out. It doesn't really make much difference. Let's say we just go with the default, which is to separate them out. Okay? And then you're done. Okay? That's a very simple way to create the project. And in this case, the other thing you want to do is under libraries, it asks you whether your project will be dependent on some additional Java libraries that is not part of the standard Java IDE distribution. In our case, we do have dependency on the JDBC ODBC library for MySQL, which is that MySQL.jar file. Remember? Yes? So this is where you want to specify that, and you want to choose the add jar. Basically means add a jar that's come with Eclipse distribution. And the external jars means that that's an external jar file that's not available in standard Eclipse distribution, which is our situation. We have a jar file that's not part of Eclipse distribution. That's what they mean by external to Eclipse. Right? So we'll do that. So we'll add external jar. And you browse through the folder where the jar file locates at. So you download my zip file, you decompress the file, that jar file is somewhere, right? You browse through that location and add the external jar. Does that make sense so far? Okay? So you can see now the library for this product. Apologize. The library for this. Maybe I should lower the volume a little bit. Better. So the library for this product includes the standard Java edition, which is by default included for any Java IDE, the Java product you have. You're going to do with Eclipse and this external jar file we have just added. Okay, then we finish. So far, any questions? So this produced an empty product space, which is called utrack. Now, the next thing you want to do is to create a package, right? Remember, of course, you don't have to use a package, but I highly recommend you use package to approach your product, right? To get modular design and easy to navigate in your product, right? So the next thing is you want to add a product. So this time you click on the product you have just produced, right click on it, and under this product you want to introduce a new package. Does that make sense? So this will be a new package for this product. And like I said, SRC's source, that goes back to the question I explained, the point I explained earlier. Eclipse asks you to whether you want to separate the source code or class file or not. If you do choose to separate them out, all the Java file will be placed under this /src folder. Of course, the root directory is named after your product name, which is utrack, the /source. That's where your Java code will be. And your class file, if you choose to separate them out, will be utrack/classes. Okay, otherwise it will be under the same folder, but in our case they will be separated. Sorry. So you give a new folder name for it. New package name for it. Now you see the folder structure for this package is utrack source, then your package name, which is CS5 story. So far so good, right? Now, of course, now what you can do is start producing Java files under this package, new Java classes, so on and so forth, right? But what I'm gonna do is to import, since I have those code skeleton I have developed ahead of time, so I will just import those code into my product. So in other words, you can import existing code into your product. Do you follow me? Okay. So I'm gonna do right click, import. Does this make sense to you? You do this because you have the code skeleton distribution from me. So you want to import the source code first before you add any source code on your own, before you add any classes on your own. So you import. You choose under general. Then you import from file system. There are many different ways you can import a code. For example, you can import from Git, import from Maven, and so on and so forth. Those are different way of distributing source code. Right? But in our particular case, you will do the simplest approach, or the most general approach, which is to import your code from the file system. Because the file system is where you have downloaded my code skeleton and save that to your local file system. Right? So you're going to import from your file system. By the way, in this workflow, if you have any doubts, raise your hand. And then it asks you to supply a directory path. You can either type your path or you just use the GUI to browse through the folder. In our case, I will just browse through the folder where my source code locates at. So Eclipse import code, you can import by a single file, but an easier way is for you to specify a folder, then select one or multiple files from that folder. So Eclipse choose the latter, which is more flexible. Because imagine if you're trying to import hundreds of Java code from a folder, you don't want to do this 100 times, right? You want to do this once for all, right? So what they do is they ask you to supply a folder. Then you can choose the code from that folder. You can choose one or multiple to import from. That makes sense? So you can even supply a filter type. So I will filter with .java file. This will show only I don't know why this doesn't work, but it's supposed to filter out all the others. So there might be a minor bug over there. But here you just choose the .java file. They're all? Yes? You follow me? Okay, then you finish. Now under this package, you have all the code imported. Any questions so far? And because I use the same package name, I don't even have to change my source code. If you have a different package name here, you have to change the package name under the source code to match your package structure. But in our case, in my case, I use the same package name, so I'm good to go. That's all. Now you can start executing the code right away. So let's try to do that. I will select this test driver 2 and run it. And your code will be showing up here. Does it make sense? There's something wrong with the code. It doesn't go to the menu. Terminate this. Oh, I think I do not have network connection. So let me get my network back, then the code should work. Okay. Then of course I can okay. You got the same thing back like I demonstrated to you last time. So within 5 minutes, you're in IDE. And the benefit of using IDE is clear, right? So let me come back here to give you an idea of what the IDE can do for you. So if I'm in this IDE, what I can do is, for example, right here, I got this auto completion, and I also got, if I mouse over it, I can even get the API of a particular method. Does that make sense? So it's very easy to do your development. And in addition to that, it gives you a really nice way to debug and add breakpoint on all that stuff. Now, to add your new code, your own code, all you do is new class under this package, and you give some name, example, and that will give you a source code to start with. Then you can work on it. Any question on this? No? Okay, we're good to go. Okay? All right. So that's so much about your product. Now, I will come back to, like I said, I will talk about Java for a little bit.
I have a question.
Yes, go ahead.
Where can you find the project? Where's the project?
Where is the product source code?
Yeah.
Oh, Eclipse.
No, online. Like, where did you
It's in
put
the
it?
solutions.
Under the homework solutions.
Oh, okay.
Yes. Now, come back to the so I think this overview will be useful for even for folks who you think you know Java and you have done Java development before. I think this will be useful anyway to do a quick review. So, and for those who have no Java experience at all, this will help you get started. Remember, a prerequisite for the class is not Java, but some object-oriented programming experience, right? So you have to know Java or something else like C++. Hopefully you know C++, right? That would be the best. If you don't, if you don't know C++, if you know Java, that's fine as well. But here I'm going to give a quick overview of Java. Okay? So what's different? Different meaning, what's the difference between Java and the object-oriented programming language like C++? There's no delete, there's no pointers, and object-oriented the way it should be. So this is, I do not necessarily agree with this statement, but a lot of people feel Java is better, quote-unquote better, in terms of the support for object-oriented programming. And the other nice thing is it's platform independent, meaning your Java code can be executed without a change when you run it in Unix, Mac, or Windows. The way a Java managed to do that is to compile your code not into binary code, machine-compatible binary code, rather to compile into something called bytecode. Then there is a Java class runtime that interprets your bytecode to the underlying machine architecture. So it decouples this binding between your binary code and your machine architecture. Of course, you can easily, as a CS student, you should easily figure out the trade-off. The trade-off there is efficiency, right? If you compile your code directly into binary code, you get the most efficiency out of it because I know which register holds what. Have you guys taken a compiler or architecture class yet? If not, hopefully you know at least inside computer you have register and so on and so forth, right? Do you? You should, as computer science students, right? You should. So binary machine-dependent binary code basically compile a code into quote-unquote assembly code that tightly coupled with your architecture. Move register 1 data to register 2 and so on and so forth, right? So you get efficiency, but the downside is it's binding to that particular architecture. So if you change to a different machine, a different platform, you have to recompile your code somehow. You might even have to change your source code. And Java solved that problem by introducing the intermediate layer, and you compile your code into bytecode to achieve this. But the downside, of course, you lose efficiency, and what else? It's very easy to do reverse engineering in Java, meaning given a .class file, I can easily recompile the source code out of it. So I did that when I was a student. What purpose I will not mention, but it's very easy to do it. I wrote a small program. I reverse engineer like over hundreds of Java.class file in less than a minute, right? So it's very, very simple to do. But if you try to do that in C++, you will never succeed in doing it. Especially for C, if you compile C++ code with -G with debugging symbols, then it's possible to do it. But if most commercial released version of C++ code is compiled with -03, sometimes -02. They do heavy optimizations, and those optimizations are often, as you can imagine, architecture dependent. So reverse engineering those code is like mission impossible, pretty much. Okay. A simple example here. This is a Java class, pair, 2 values. And so on the top is a class definition. And that class has no method I have only no constructor or destructor. By default, if you don't supply one, both the constructor and destructor for a Java class is simply an empty method, do nothing essentially. Okay. And then down below is another Java class that shows you how to call and use the Java class on top. Okay. And in this example, I have two member functions for the second Java class. And the first thing is I'm gonna have in the first function f, I will have a local member variable called n equal to 1. This n is, remember, this is not a class-wide member variable. It's to this particular method. Does that make sense? So it's not a class-wide variable for class pair example. Rather, it's a local variable for this function f. Then the first thing is I produce an object instance from the pair class. So class is an abstract definition. This P is a specific object instance of that Java class, which holds two member variables, which is x and y. So the size of this class is at least 8 bytes. Suppose each int is 4 bytes. This class P will occupy at least 8 bytes in your memory space, maybe even more, because Java has some addition for each class. I have some additional metadata information attached to it. In fact, the space overhead of Java class is pretty significant. In this case, P, the bare bone implementation of P will require only 8 bytes. But in practice, if you look at the memory footprint of this Java class, typically it will be way more than 8 bytes. Okay? But at least 8 bytes. Okay? Then I assign some values to the member variables of P, x equal to 2, y equal to 3. I print out n. What do you expect? The value of n should be 1, right? That's what I initialize n to. I print out the value of x, which is a member variable from P. Here, obviously, is 2. Here comes the interesting part. I call another function g, which takes two parameters. One is an integer parameter. The other is a pair class parameter. And I pass n and p as parameter values for those two parameters. You follow me? Then I define g down below. Now I have two parameters, num and ptr, num and pointer, to simulate the fact that I have a reference to a pair class and I have a handle to an integer variable. And inside that function, I reset num equal, I set num to 17. I print num first. In our execution, since I call function g with n equal to 1, so what do you expect here? What do you expect to be the value of num here? Obviously, it should be 1, right? I reset this to 17. Then I print the number again. That should print out 17, obviously, in the scope of this function. I print out the pointer of x. Since I pass p as ptr, it should print out the value of x of p on top, which is 2. Then I reset x equal to 100. And finally, I reset this pointer to num, this object instance to num. Then I return function g. Unfortunately, here I have the answers. I should hide the answer and ask you guys, if you claim you know Java, tell me what will be the answer on top. Okay? But anyway, let's go through this together. When you print out, when the function g returns, we are back in function f. Now I print the value of n again. What should be the value of n? Should the value of n to be 1 or 17? 1. What does it tell you? Java's function call with respect to an atomic data type like integer or float is passed by value. Or in other words, passed by copies, passed by values. Meaning the function call will make a copy of the atomic data type. Whatever change you made to that copy stay in the scope of that function. When the function returns, everything is thrown away. And then you go back to the original copy of your variable, which is 1. Does that make sense? What about if I print out the value of x? So somebody just reset X to a sound or video, right, instead of integer. Interesting. First of all, Java will reject that because there's a type mismatch. All right. Okay, so what is the value of X now? Is it 1, is it 2, or 100? Well, interestingly enough, it's 100. What does it tell you? It tells you for object instance in Java, function call is by reference. So instead of make a copy of the entire object instance, when you pass an object instance to a function call, it passed by reference, kind of like a quote-unquote pointer to the object. So whatever change you made within that sub-function to the object instance, it will be reflected globally in the callee function. Does that make sense? And the other interesting thing here is, remember, not only we change the value of X through this pointer, we actually reset the pointer to now, but it doesn't affect the value of P. What that tells you is the object instance itself is passed by reference, okay? But the pointer to the object is passed by copy. There are two subtle things here. The object instance itself is passed by reference, but the pointer itself is passed by copy. So whatever change you make to the pointers is not going to be reflected when the function returns. In other words, you will not lose the handle to this object instance P, even if you set pointer to none in the function call. So I think this simple example demonstrates to you some basic understanding about it. Make sense? And what you should know is, next what you should know about Java is there should be a main class, main function defined in at least one of your classes in order for your Java code to be executed. You can have multiple classes, but one of them must have a main function defined, and this main method must be inside the class and must be of type public static void. What that means is it must be a public method. It must be static method for a class means that it is a class-wide method. You don't have to instantiate an object instance in order to call that function. Does that make sense? If it's a static function of a class, you do not have to instantiate an object instance in order to call the method. You can just use the class name and call it. Yes. Void simply means it doesn't return anything. And this main method expects a single argument, which is a string array. This is slightly different from C++ or C code, where it has two arguments for a main method. Right? It needs an array and the size of the array. In Java, by default, you can know the size of the array from the array itself. So there's no need to supply that second parameter. What about standard in and standard out? Well, you use the print line or print method from the system package. And system package has two classes implemented for standard in and standard out, which is system.out and system.in. But oftentimes, you might use some advanced class to wrap around this standard in and standard out to have flexible, easier control of interacting with standard in and standard out. For example, in this case, I can define an input stream reader, which is a class built based on system standard in. So I pass standard in as the input interface and a member variable to input stream reader. And then I pass input stream reader, this object instance, to construct another object instance for buffer reader, which while I do that, because buffer reader allow you to read from an input stream line by line. So it's very easy for you to do controls over input and output. Does it make sense? As, for example, you can also construct a buffer reader not from an input stream reader, but from a file reader, where you can supply a file. This allows you to read from a line by line from a file instead of standard in. So this simple example demonstrates to you Java is really flexible. Computer science, especially when it comes to programming, is reduced to three things, I think. Okay, your brain, of course, then Google plus Stack Overflow. Okay? If you don't know how to use those, 10 years ago it's okay, but now if you don't know how to use those, I don't think you qualify as a CS student. So for example, you may wonder, how do I read a line from standard in? You can ask me, of course. Or you can Google Java read a line, standard in. That'll solve your problem like in 2 seconds. So naming convention, so I'm gonna skip this. Basically, use common sense and good practice. Don't have funny names in your class. Okay? Some points on the meaning of static, final, and public. This is universally true for pretty much literally any object-oriented programming language, right? So if you have one experience with some object-oriented programming language, you should have no trouble in understanding this, right? Static means that it's one member shared across all instances of that class. Either this is a static member variable or static member function. So once it's static, it's shared across all instances of that class. Does that make sense? Final means that it's kind of like a constant, similar to CONST. Public, private, and protected is similar to C++, right? So private means that it can only be seen by this class itself. Protected means that you can see it from your friend classes. Like in other words, like you package the classes from the same packet and so on, and those you declare as your friend. Public means any other class can see this method of member variable of this object instance. Okay? So these are similar to C++ or any object-oriented programming language experience you had before. Next big thing is inheritance. There are two main mechanisms, I should say, with respect to inheritance. Right? Inheritance is a fundamental concept in object-oriented programming. Right? The idea is I have vehicle, but under vehicle I may have car, I may have truck. Then under car I may have sedan, I may have sports car, and so on and so forth. So the idea is I have a root class that defines some common properties, like vehicle must have wheels. Right? How many wheels, I don't know, but you have at least have one wheel, right? At least that's my understanding of vehicle, right? Things might change, you never know. But so far, every vehicle must have wheel, must have an engine, and so on and so forth. So those are common properties. But then I distinguish truck and cars, and then under car I have sedan, like 4 doors, and sports car that only have 2 doors. Those are class-specific properties. Okay, so that's kind of like a basic understanding of inheritance. And how do you do that in Java? You have two things. One is called extend, one is called implement. The difference is, here's the difference, right? So just like in any other object-oriented programming languages like C++, I have concrete class and I have abstract class. Abstract class is a class where you define the interface of the class without actually implementing those methods in the abstract class. Does that make sense? Okay, that's what we call an abstract class. In Java, you define an abstract class using something called interface. If you declare a class as interface, that's the same as an abstract class in another object-oriented programming language. Okay? Once you understand that, you can understand the difference between extend and implement. If you inherit from a concrete class, you use extend. If you inherit from an abstract class like interface, you use implement. The keyword is actually pretty telling in terms of what they mean, right? If it's an abstract class is your parent class, in order to inherit that parent class, you have to implement those methods. Because the parent class itself have not implemented those methods. So you have to implement them. Provide the implementation for those interfaces. If parent class is a concrete class, you want to inherit that class, while you get everything that class has implemented for you, but you may have additional things you want to extend that from. So you use the keyword extend. Does it make sense? So that's the difference of the two.
give you a simple example. So I have a base class called base class. That's okay. It's kind of like last time I found the oldest age, the largest age value from the student table. Well, long last name. Okay, long last name. Not good news for me, but you guys go. My last name is Lee, right? So only 2 letters. So not so good news to me. Meaning that I'm not the one with the next age. Now, base class has only one member variable, which is inheritable member. Has no member functions defined. You can define member function as you wish, but here I have no member function defined. I only have one member variable defined. And then I have an interface called move, which defines 2 methods. One is called go straight, turn left. You can think about this as Google car, right? Auto-driving car. But I did not define how to implement those methods. Then I have a class called derived class, which will extend the base class, which means I will grab the member variable you have, which is inheritable member, and implement move, meaning that I need to provide implementations for those 2 methods. Go straight and turn left. And in addition to those, I may have my own class-specific member variable and member functions. Here I didn't supply any, but if you wish, you can. Any questions so far? Finally, Java has an exception handling mechanism that's similar to C++, but one big difference is in C++ and some other object-oriented programming, handling exception is optional. It's not compulsory, but in Java it is compulsory. Meaning that in your code, whenever you call a class function that potentially can throw an exception, it doesn't mean it will throw an exception in your execution, but as long as it has a potential to raise an exception, you need to catch that exception and handle it. Okay? If you look at my code skeleton, it's definitely not a good example, but I go for simplicity. So because my purpose is to demonstrate how to connect to database, not really to build a commercial level system, right? So what I do is I use a try-catch block for all my code, which is a very bad practice, so I need that. But it's done out of simplicity, right? So I want to get the job done and be done with it. So I catch everything. Because all exceptions in Java are extended from a base class called exception. So you can go about distinguishing those exceptions as much as you want. At the end of the day, I only need to catch exception. I don't care what kind of exception you throw. It must be a children class of exception. So I catch your parent, I catch everything. So for simplicity, that's the approach I have taken in my code skeleton. It doesn't mean you have to do the same as I do, but many of you, I suspect, will do the same thing as I do. But some of you might want to go the extra mile to make your code really professional looking and all that stuff. Go ahead, totally do that. But if you don't want to do that, that's fine. Just use one big try-catch block, like what I have here. For example, in this case, foo.bar, then I have I equals 17. When you do this, you may potentially have an exception, which is array index out of bound. Right? Whenever you try to access an array element, you may step outside that array element you have, array object you have. So you have to catch that exception. You can be very specific in terms of the exception you try to catch, like what we do here. Or if you do this, the problem is if that class foo.bar potentially throws some exception, either by the method itself or whatever going on inside the method may throw some exception, you are not able to catch those exceptions. And the compiler will still complain about that. Because you are only catching the index out of bound exception. So if I change this to catch, so like what I do here, I try and catch everything, called exception. Then you can use one try and catch block, catch everything. Does that make sense? And typically what I do is to use print stack trace. Let me demonstrate this to you, right? What this means. I'm going to execute this code. I'm going to do this. Then I will purposely supply a EO form SQL statement. A really bad SQL statement. Obviously it's wrong, right? What happens? I will catch that exception, and you can use this to debug your code. It even tells you where the error comes from, right before the from clause. Does that make sense? And if you look at the stack trace, it shows you which line throw the exception, line 66. That's exactly when I try to execute this statement, because the SQL statement is wrong. Does it make sense to you? So that's simply what I do. I just call print stack trace. It will print the stack. I hope you understand what is the stack, right, in function calls. If you don't, I'm not going to explain that in this class, right? But if you have taken a compiler or something like that, you should know what is the stack trace for a sequence of function calls. So we'll print the stack trace leading to this exception. So that's very useful for debugging purpose. Does that make sense? Okay, so that's exception handling. Then one thing I didn't have here on the slide is typically for trying to catch block, there is another block called finally. Literally, it's called finally, right? So look at my code. After catch, there is finally, right? So what this does is when an exception is raised, your execution will skip what's remaining in your code and jump to the catch block and execute whatever in the catch block. Does that make sense? But there are some other state variables that you haven't properly reset to their initial value of. For example, one good example of that is what? Is you may still have an active connection to the database server, and you want to make sure when you exit from your code, you disconnect that connection to the server. Why? Most database servers have a limit on the total number of active connections we can have to the database server. To make sure we do not, because every active connection you have to maintain, the database server has to maintain, it uses resources from the server. So you have to set an upper bound for that. Believe or not, in the past, every semester I teach this class, I run out of the upper bound, no matter how high the number I set to. The reason is some of you use recursion, whatever, without care, and inside recursion you know. So one of you end up taking all the resources, and that could be a denial of service attack, right? So all your classmates cannot finish your work. You are the only one get A, right? So if you do that. So coming back here, the point is you want to properly reset important state variables to a safe state. You may argue, why don't I just do that in catch block? In my catch, whenever exception occurred in the catch block, I disconnect from the database server. The problem with that is if you do run into an exception, yes, that will be taken care of. But what happens if your code executes normally and didn't raise any exception? Then the catch block is never executed. Does it make sense? So the finally block is executed after either a normal execution of your try block or after the catch block. In other words, it will be executed regardless what happens. So it's a good place where you reset important state variables. So I admit the try catch block, the way I use it is a little bit brutal, but you can tell in my coding here, I still try to observe, clean up important state variables like connection. So for example, here I will try to close the connection if it's not null, meaning that I do have active connection.
Do you know if, like if we're debugging, say, we hit a breakpoint that is after we make a connection, If we stop the,
after you lose the connection.
no, so we make the connection, we're debugging, so we hit a breakpoint.
Yes.
If we stop the program there, will the binary block still execute then?
That's a good question. I actually do not answer it. What you're saying, let me repeat the question. What he's saying, might, right? Or might.
Correct.
Correct. Okay. What he's saying is, if I have an active connection to the data server, then I set a breakpoint for debugging purpose. Then after I'm done with my debugging purpose, I exit the program. Will that connection be reset? I bet the answer is no, by default. But most data server also has a timeout mechanism in place, meaning that if you have an active connection that says I see no activity for some period of time, I will reset that connection. Does that make sense? But you always want to be proactive, meaning that as a programmer, you want to minimize. I think I mentioned this in slide. What is computer system? What is a system? What's database system? What's a system? What's the operating system? All file system. All this computer buzzword has, most of them have the word system in it. What's system? System is efficient and safe use of limited resources. That's system. If you think about that applies to human society as well. What is a democratic system? Efficient, safe use of limited resources. Limited is a keyword because if we have unlimited resource, you don't care, right? Does that make sense? If we have unlimited resources, do we care about those debates about social security? Do we care about those debates about tax? We don't. Unlimited resources. What you want, I give you what you want. But unfortunately, we do have limited resources. That's the same thing as a computer is concerned. So a system is safe and efficient use of limited resources, meaning that as a programmer, when you build a system, you want to make sure your code is both efficient and safe. Of course, you can rely on the data server to reset the connection for you, but that's not good practice. In other words, do not rely on somebody else. At least that's the way I do things, right? Whenever I can take care of something myself, I will do it myself. Right? Of course, it doesn't mean you don't trust others, right? There's a fine line between this, right? So you have to work in a team as well, learn how to trust and delegate tasks. But at the same time, you have to do your share. Okay? So that's the same for computer systems, that's the same for our society, it's the same for taking this class. Everything go under the same principle. Okay? Any other question? I think I will stop right here. In my slides, I have a few more examples. Some specific Java examples, and some discussion on package, and so on and so forth. I think those are very easy to understand. You read, you should know Java. Okay? By now, if you don't know Java, you should be able to code in Java. If you know Java already, hopefully this will reinforce your understanding on Java. Okay? That's it. I provided a link on the course website that give you the direct link to download Eclipse. You don't have to use Eclipse, like I said multiple times. Personally, I'm not a big fan of Eclipse either, but it's among the IDEs I know of, this one is easy to learn, as I demonstrated today. So that's why I recommend, I use this as a demonstration. But I typically do coding in Emacs, okay? But Emacs, if you want to be good at it, you have to use a lot of plugin, macro, and all that stuff. So sometimes you even have to write Lisp macro yourself. So I'm not going to go that path. Right? So I go with this for demonstration purpose. All right. So any questions? Not. Back to the lecture we have. So what I will do today, as I promised, I will wrap up the discussion on SQL and try to start something new. By the way, homework 3 is due on Wednesday. Then on Monday, I will have quiz number 3. Next Monday. Then on next Wednesday, not this coming Wednesday, but the Wednesday next week, we will have our midterm, which is right before your spring break. A midterm, like I said, open book. You can bring your laptop as long as you stay in our course website. You cannot step outside that. Once you step outside that, you get 0, you are evicted from the midterm test.
But you can refer to slides, lecture slides, all the solutions I posted, homework and quiz solutions. By Monday, I will finish. We will finish quiz number 3, and that's essentially the scope of your midterm test. Homework 1, 2, 3, and quiz 1, 2, 3. Does that make sense? So test up to the end of SQL. Okay, and you will have all the resources available to you. And the way you prepare for your midterm is to think about the homework problems and the quiz problem. If you feel you have no trouble in doing the quiz I have done so far, no worry, you will have a smooth ride during midterm. You will sail through it. If you have trouble in solving midterm tests, you rely on something like Sesame open the door, like I said last time. There's no such magic, unfortunately, for your midterm, right? So door will not open automatically, right? So you have to prepare for it. But bottom line, it's not that hard. If you do, as long as you do homework, you do a quiz, I guarantee you will do well in the midterm. Okay. Now come back to SQL. So this is where we stopped. We talked about group by and having. I'm not going to repeat myself once more. So we'll step into new terrain here, right here. So one thing, we talked about this before, which is the insert statement. How do you update a table or schema you have previously defined already? You use the keyword insert into, followed by the table name, followed by a column list, and the keyword values, followed by a list of values. And there is a one-to-one correspondence between the values from the value list to the columns in the column list. So the first value goes to the first column and so on and so forth. The reason they do that for you is to allow you to specify values for a subset of columns in a schema, meaning that you do not have to supply values for each single attribute in your schema if you don't want to, using this approach. So for example, I can insert into bold by specifying value only for BID and color. But if you do not supply list of columns, that means you want to supply values for all columns, like the first example shown there. And the sequence of those values is in the same order as the attributes you have defined from your schema. So if you don't supply a list of columns, the order is automatically taken from the order of attribute in your schema definition. Okay? You can also do what we call bulk insert, meaning that instead of inserting one value, one record at a time, you can insert multiple records in a bunch. So for example, I can insert into a temporary table which has only bold ID as its schema. And here I select all the bold IDs reserved by serial 22. Does that make sense? So that will do a bulk insertion rather than inserting one by one. Of course, when you do bulk insertion, you want to make sure the schema of your SQL statement here, which pretty much refer to the projection list from your select clause, must be union compatible to the schema of the relation you insert into. Union compatible means that their schema are the same. The type of the schema is the same. Right? That's what we mean by the union compatible. Delete and update. Delete, basically, the syntax of delete is on top. It asks for a where clause to specify the condition for deletion. All records satisfying the where clause will be deleted from your base table. That's what I do here. You can also do update using the keyword set and where clause. I think we've gone over this before, so I will skip this. Three-value logic, and now I believe I talked about this before, so I will skip this. The last major thing in SQL is called joins. In fact, we have talked about joins already, meaning that that's why I went ahead with homework 3 without even talking about this, because you can do your homework 3 without knowing join at all. Because another way to express join is to simply use from and where clause to specify your join condition from multiple tables. Because conceptually what happens is you produce the cross product for all the relations in the from clause, then you use where condition to enforce the join condition over that cross product for those relations, the instances from the from clause. But sometimes for two reasons. One is sometimes people want to explicitly tell other users I'm doing a join. And in those cases, using a join keyword is more telling, it's more explicit. Right? So that's the reason why you want to use this join approach. The other thing is a little bit subtle, which is you want to do something called alter join, which is not something we are able to accomplish using from and where clause. So far, the way we approach join is to use from and where clause, and that gives you what we call an inner join. An inner join. You can think about inner join as records from your cross product that satisfy the join condition. That's essentially inner join. Period. Okay? So that's inner join. Inner join is all the records from your cross product that satisfy the join condition.
How do you do alias inner joins? So like using the keyword as?
You mean like this? All you do is treat this as a relation. Right? Then you can still write, I think we went over this, right? Well, example. Okay? So it's no different from a base relation. We talked about this before, so but since you ask, that's how you do it. Now, okay, we talk about inner join. Next, we're going to introduce something called outer join. If all you care is inner join, you actually don't have to learn this keyword join. You don't have to learn this keyword. But sometimes you care about outer join. Outer join is all those in inner join, which means all the records from the cross product satisfy the join condition, plus something additional. What is that something additional? That's what I'm going to talk about next. Okay? Do you follow me? So first, let's look at the syntax of this join keyword. By the way, for your homework 3, you don't have to worry about auto join. All the joins by default, unless I clearly specify in the context, all the joins in this class refer to inner join. That's why you can do your homework 3 without even learning this keyword join, because you can express inner join always as a from and where combination. Okay? Now that being said, let's look at this join keyword. Again, I'm going to use this regular expression. First of all, you have an optional before the keyword join. So a table name, join table name on qualification list, meaning table 1, join table 2, using that qualification list. Do you follow me? Do you follow me? And that's kind of like select from table 1, table 2, where your where condition is that qualification list. It's the same thing. If you ignore this optional part, the square bracket. And in the optional part, in the first level, you already have a choice, which is the vertical bar between inner and outer. That's the first choice you can make in the optional part. Does that make sense? So you can do select table name, inner join table 2, table name, qualification list. You can also do select table name, outer join table name, qualification list. That's the first level choice you have to make. But this choice is optional, meaning that you don't have to supply anything. By default, if you don't supply anything preceding to the join keyword, what's the default? Default is inner join. If you don't supply anything, database system will treat it as an inner join. Does that make sense? Okay? And then if you go with alter join, before the keyword alter, you have to supply one of those, which is another choice you have to make, which is left, right, full alter join. Meaning that you can do select table name, right alter join table name. You can also do select table name, left alter join table name on qualification list. Finally, you can also do select table name, full alter join table name on qualification list. Those are all the possibilities. You follow me? Let's go over those one by one. So if I do this, okay, this is the basic choice. I go with inner join. And this query is the same as this query is the same as okay. This query inner join is the same as from where approach. Okay, so I don't think I need to say more than that. And then SQL also has a keyword called natural join, in addition to inner and outer join. Inner join, both inner join and outer join are what we call theta join. You remember theta join? From relational algebra discussion, right? But SQL also gave you a keyword called natural join. Natural join is nothing else but the same natural join definition we have seen from relational algebra. So I don't go into detail, right? When you use natural join, you do not have a qualification list because the qualification list is automatically populated. You quality condition on all common attributes from the two input relations. So that's inner join. Here the example is exactly like this query I have here. I'm gonna skip this. This is trivial. Okay. All right. So by now you should feel this is trivial. Okay. I suppose you have already worked on your homework 3. If not, then you should hurry up. Next, we talk about alter join. Alter join has 3 types. All we need is to understand one type. Then the other 2 types explained by themselves from their names. Okay? So let's look at left alter join. That's pretty much all we need to know. Once we understand this, the other 2 are trivial. So the keyword, we're going to do the same query as inner join. All we do is change the keyword inner to left alter, like this. Okay, what does it give you? First of all, it's clear, like I defined on the whiteboard. It gave you those records satisfying the join condition from the cross product, which is these 2 records. Right? So alter join must have these 2 records. That's for sure. Something additional. What are those something additional? Someone make a guess? First of all, left alter join must have something to do with left. Right? You follow me? Which means, which is left here, by the way, in this version? Theta, right? So it's this record plus something from the thetas, right? That's what we can guess. We're not using a mirror here, right? Left means left. Okay? The thetas, right? Not mirror. So what are those from thetas we want to involve in the alter join? Someone make a guess? Make a guess. Yeah?
I will return the s.sid and the s.s name data, but because there's no reservation for that person, it will be blank or maybe null for that one.
Excellent, right? So auto join, the purpose of auto join is, I'll give you a scenario for this, right? I want to produce a manifest list of all the sailors in my club. And in addition to the sailor record itself, I want to show when is it applicable. I want to show the boats the sailor have reserved. But if you haven't reserved anything, it doesn't matter. I will still print out the basic information about that sailor. Does that make sense? So that's kind of like a manifest list of all the sailors and the boats he or she has reserved, if he or she has reserved anything. You cannot do this using inner join, because inner join will disqualify any sailor who hasn't reserved anything. They will be removed from the output. That's not what I want. Does that make sense? And to do that, you use left outer join. That will show you everything satisfying the join condition. In this case, every sailor who reserved a boat, plus everything from the left-hand side, which is sailors in this case. You may wonder, what about in the final projection list, I project out one or multiple attributes from the right-hand side. Then for those records from the left-hand side that do not have a join condition, I have nothing to project out for. She answered that already, which is, you use null value or some default value. What's your name? Bing. Okay, she answered that. You use null values. Okay. So that's the opposite. So you see, it includes everything from the inner join, those who reserve a boat, plus what? The record from the sailors, in this case only one such record, who does not satisfy a join condition, but I will print out those records, every single such record from the sailors, and leave null value for the attribute from the other side that you do not have a match for. Any questions regarding this? Yes, Curtis.
So, what if it's not permitted to be null?
Louder.
What if the record that ends up being null is not permitted to be null?
Oh, not permitted to be null is with respect to your base schema. In SQL, I'm defining a new schema. There's no constraint defined whatsoever. Two different things. Right? So it's a smoke-free campus. You cannot smoke on campus. You have a student here. But when you go outside the campus, no, it's a bad example. I'm not encouraging you guys to smoke. But you got my point. Right? Speaking of smoke-free, did I mention this? When I was first learning the language, right? I was in Singapore. Then somebody tell me I was in NUS, National University of Singapore campus. It says smoke-free. Free means free, right? So I thought smoke-free means you can smoke freely. Not only you can smoke, you smoke free. I mean, that's like, oh my gosh. Right? Luckily, I didn't get in trouble for that. But you know. All right. So translate to our language. When you define a constraint, you have to have no ambiguity. Right? Don't behave something like the English language, smoke-free. You know. Totally messed up. All right, right auto join. If you understand left auto join, you can understand right auto join, right? Same example. Here, as a club owner, I want to show all the boats I have, and for each boat, I want to show the associated sailors who have ever reserved that boat. But if a boat has not been reserved at all, I still want to show that boat regardless. Then you use right auto join. Using this. Or you can use the left auto join by flipping the order of boats and reserve. Boats and reserve, you can do the same thing. So here is the result for the right auto join. Does that make sense? What about full auto join? One record from both ends. Okay? So I want to show all the boats I have, and for the boat who does have a reservation, I want to show the reservation information. But at the same time, I want to show all the reservation records, even if there is no boat matching for it. In our case, you will know, even without executing this, you know the result of full outer join between the two is the same as the right outer join between the two. Why is that? And someone answer me this question. So for this particular query, right, full outer join is guaranteed to be the same as right outer join. Why is that?
Because you can't have a reservation without matching.
Yes, because the foreign key constraint between the two. You cannot have a reservation record that has no matching boat, because boat ID on reserve is a foreign key to the boat table. So you guarantee the outer join, full outer join, the same as right outer join. But this is not always true. If you do not have a foreign key constraint on your join condition, you may have record from both ends that have no matching record from the other side. Do you follow me?
So, in the right outer join slide, you said that, oh, if we switch the two tables, you get, and then you use left outer join, you get the same thing, right?
Yes.
What if we don't switch the tables? Would it give us an error because the relation is the opposite direction?
No. It will not give you that error. It will give you what the definition of record outer join does. Meaning, every reserve record plus the boat, it has reserve on, which is essentially every single reserve record.
Okay.
Plus, but some reserve record will show multiple times if it match with, each reserve match with only one boat. So that will show exactly the reservation record.
I have a question about doing a right outer join, but using the example on the left outer join slide.
Okay, let me go back. You talk about this.
Yes.
So I flip you want to flip the order of reserve and sailors and keep the left outer join.
So, but my question is, if you use this exact same query, but you use a right outer join instead, in the select there's an SSID. Would it just substitute the R.SID because R.SID exists, or would it leave a null to that?
So if you keep this as exactly as it is and change left to right outer join, by definition what it does is everything from the inner join, meaning all the matching records, plus everything from the reserve. But the key observation here is, again, CID is the foreign key to the reserve table. So every matching record in the cross product has already covered all the reserve records. So in this case, if you change left outer join to right outer join, it's essentially the same as inner join. Because you have no reserve record that does not have a matching join record from the sailors. Make sense? So it's a kind of the exact same question as we asked. Good question, okay? So full outer join. Finally, we have something called views. In database design, this is a conceptually very useful construct. The idea is that we want to have good ER design, and we want to have good schema formation, and so on and so forth, right? But sometimes for the convenience of understanding your data, and for the convenience of writing SQL queries, I want to have some additional interface to my database. Give you an example. Suppose I realize my managers, he or she loves red color boats for some reason, okay? Maybe a Republican, okay? Yes, okay? And so he or she always queries about red color boats. Why? Because whenever he or she go on sailing, this person wants to be on a red color boat. So this person always come back and ask me how many red color boats is available now. How many reservations we have made on those red color boats. If you keep doing this, what's your choice? Well, you can write this query all the time, which is, forget about this query view, you can write this query, group by and have group by query, right? I do a join between boats and reserve and make sure I only talk about red color boats and group by boat ID and show the reservation count. That tells me how many reservations have been made on each red color boat. Does that make sense? Yes? So you have to keep typing this query, right? If it's a typical customer, you do this 2 or 3 times, you tell the customer, I'm done with it. Do you want a reserve boat or not? Right? if it's your manager, you obviously cannot see that, right? You say, oh, don't worry, I will do this for you. But you want to save yourself trouble, right? From typing this query all the time. So you can use something called view, meaning introduce some additional quote-unquote interface to your database. So you create a view called ret as this. And once you have done that, next time you don't have to type that messy group by query again. All you do is you can do things like this. Does that make sense? So ret is not a base table in your design, but using view, it gives you a convenient way to grab this data without re-executing that, re-typing and re-executing that query all the time. Does that make sense? Okay, so conceptually it's a very useful thing, right? Next, I'm going to ask you guys a question, which is, what is the impact on efficiency when you use views? What are the impacts to efficiency when you use views? Can someone tell me this? There's a trade-off here you want to explore.
Every time it's using a view, doesn't it has to execute that select statement? So it's kind of the same cost, I guess, I think, as having a nested query in your from clause.
Yes, excellent. So pretty much every time you execute this view, you're going to substitute the definition of view into this query, so this becomes a nested query block. And people leverage on that observation. If I'm doing this over and over and over and over and over again, why don't I cache the result once more? So I execute this view definition once, cache the results in ret, then I no longer need to do this expensive nested query. Rather, I will reduce my query to a hash table lookup from this cache result for the ret. Do you follow me? And that's something called materialized view. So you materialize the view. But there's a catch. There's no free lunch, right? What's the catch? How about tell me what's the catch?
Sometimes the data will be old, it'll be updated.
Yeah, if you have updates to the tables that used in the definition of your view, any single update you make over there, you potentially have to update the definition of your view as well, if you have a materialized view. If you have a conceptual view, as a dealing approach has suggested, update is agnostic to the view, right? Because you always go back to the raw table to execute the view definition from scratch. You follow me?
So if you materialize a view, is it, so is it like, I guess, update that view every time like you insert into, I don't know, one of the other tables that are there, or does it only do it like when you use reds again?
Yeah.
Does it like say this is invalid?
Yeah. Yeah, the naive solution is to, when you use a materialized view, what you're saying is something like in programming called lazy evaluation. Meaning that I know my view is out of date. But you don't have to evaluate this view to the most fresh data until you are asked to return something from the view. Why this lazy evaluation might save you something? Because if you are so eager in updating the view, you may end up in oscillating state, meaning that you update something, you update the view, and then you delete something, the view go back to its original state. I keep doing this, then you're doing all the wasteful jobs. If in between there's no one come and ask for your view, then there's no point for you to do the update. So lazy evaluation might save you in the long run. Okay? There are more things that we can say about this. Unfortunately, I have to stop right here. Not for the class. Okay? I want to continue on a little bit. Stop here for the discussion of this. I want to use 1 more minute. Okay? So this is a rich topic of research. So, there are also called something called half materialized view, meaning that I only materialize the part of the view that depends on quote-unquote code data, so that rarely gets updated. And for the hot part of the view, I do not materialize that. Rather, I will execute only those parts live in real time. So this is a rich topic. So here is an example of the view. I think I will stop right here. Then on Wednesday, remember, homework 3 is due, and I will use another 5 minutes to work on SQL to move on to new topics. Okay? Yes. Yeah, sure.